All right, to finish out this lecture, we're going to talk about the tools that we can use to conserve our natural resources and also some strategies that we use. So we're going to go over the 3 S's that you need to know and the 4 conservation strategies. Now, this stuff is not in your book, so you need to pay attention and take notes. Not in your book. All right, so first off, we're going to talk about what are these 3 S's. The 3 S's are basically ground rules for conservation. In order for conservation to take place, these 3 things need to be considered and thought about and used. And they are sustainability, sound science, and stewardship. See the 3 S's? SSS. Okay, so that's why they're called the 3 S's. So let's take a look at each one of these real briefly. Okay, number 1, sustainability. Let me turn my notes page here. Okay, we've kind of talked about sustainability, and basically it means a wise use of your resources or wise management. And so let's define it here. Sustainability is to use resources in such a way to ensure they last. In other words, wise use. Okay, this is obviously very important in conservation to you have a sustainable use of that resource, making sure that it's going to last in the long term. So that's the first S. The second S, sound science. What is sound science? Sound science is basically objective research using the scientific method. Scientific method. So it's doing solid data collection, collecting multiple sets of data, analyzing. And another key is repeatability. Okay, in sound science, basically scientists use the scientific method, which we're going to talk about in just a moment here, and they come up with a concept. So if there's a scientist out there and they happen to notice something, make some observation, then instead of saying, well, that I've seen 5 dogs at the park today that are cute, therefore all dogs are cute. That might be their theory. All dogs are cute. And so then they're going to go and do research on all dogs are cute and how they're going to go about collecting that data. And they're going to write up a paper using that scientific method. And then they're going to have that paper sent to their fellow peers, other scientists who are going to read through their stuff and say, oh, yeah, that sounds like good science. And I can repeat that. And I'm getting the same results. And over, and it's repeated. And we still get the same results. Therefore, it is considered to be sound science. This slide here shows the idea of the scientific method. Okay, you make an observation or some observations, and those observations lead a scientist to create a question or to question why they notice these observations, and that question leads them to a hypothesis or a possible or probable answer for these questions. Now, once they have a hypothesis, they predict what the outcome will be, and then they create tests to test that. Okay, well, how are we going to test to see if it always rains when the weatherman says there's a 30% chance of rain? Well, we're going to go through years and, collect data and analyze the results and check out all these percentages. And then they're going to publish their results in a paper. Now, if the results right here fail to reject the hypothesis, and that's what they're trying to do. Scientists are constantly trying to disprove themselves. Okay, it's very easy to prove yourself. You can say, well, see, I'm right. It's a lot harder to disprove yourself. You basically want to come up with a theory or a hypothesis and then try and disprove it. That is sound science. Okay, so you try and disprove that hypothesis. If you do disprove it, you come up with a new hypothesis. If after years of studying and gathering data, you haven't disproved it, then it becomes more of a theory and it goes out to be tested by other scientists. So these are just visuals to show you that. The reason we like to point this out is that you want to make sure that you are not falling for the junk science, okay? Junk science. That's these infomercials that are saying, hey, you know, all you have to do is take this pill and blah, blah, blah. You're going to be an amazing person. Or politics loves junk science. Politics. They're really bad about using junk science. So if you ever hear something that sounds slightly fishy to you and you're like, really? I don't know about that. Then think about it. Do you think, is there sound science to back up what they're saying? Think about how it all comes together and make sure that you know where those sources are coming from. And that's what peer review articles and all that comes into play. So sound science is the second S. It's really important that we're using the scientific method and proving our data. The last S is stewardship. And stewardship is basically doing something because it's the right thing to do. Doing something because it's the right thing to do. Okay, you're walking along the sidewalk at the park, there's trash floating by. Do you ignore it or do you take the time to bend over, pick it up, put it in a trash can? If you want to practice stewardship, you bend over, pick it up, and put it in the trash can. You know, volunteering and doing things because you know it's the right thing to do. It's not always what you want to do, but you know that it should happen. And for conservation to work, everybody's going to have to practice some stewardship and doing the right thing, even though it's probably more of a pain in the rear end than you would ideally like it to be. All right, now let's talk about the tools or the strategies. These are tools for actually going about and practicing conservation. And there are 4 of them. Again, these are not in your book. We've got preservation, restoration, substitution, and maximization. Okay, so we'll look at these real quick. Preservation, right back to John Muir. You can always think of him. This is the idea of keeping the wild wild. Here, put this, keep the wild wild, to set aside and preserve an area. So we can help conserve natural resources by preserving some of them, and our national park system is a really good example of this. Okay, you can go into national parks, you can camp, you can hike, you can enjoy them, you can explore. You cannot take things out of them. A lot of like places, Joshua Tree, for example, where there's very limited resources such as water, when you go backcountry camping there, humans are not allowed to use the water that's available. You have to carry all your water in. All the water that's in the park is there for the wildlife, and there are strict rules for that. But the resource is still open for humans to go and enjoy, and that's a real key part. If we can't enjoy the resources, then why would we really want to protect them? So preservation is key. We've got national parks. There are a lot of preserves around here. What else? What else did I write down? Monuments. Joshua Tree was a monument before it was a national park. So these areas really set these very nice natural resources aside for humans to enjoy, but not necessarily to use in terms of chopping down the trees to make paper type of thing. All right, number 2, restoration. This strategy in here, you're basically trying to fix and repair a resource. You're trying to restore it to its natural state. And we see this being used more and more. In fact, one of my students just did a project on the San Diego Salt Marsh Restoration Project, which was really interesting. They used to be salt manufacturers, and they bought Conservancy bought back the land, and they're restoring it back to these salt marshes and replanting the native plants. Salt marsh restoration. The big problem with restoration is that it's very costly. It costs a lot of money, so you've got to have a lot of money to start with. And the other issue is that we can never get it back, get it fully back to what it was. to what was. Okay, we cannot build a complex ecosystem like Mother Nature can. So the best we can do is try and put it back the best we can and hope that nature will take hold and rebuild all those very intricate connections and systems. But restoration is definitely another strategy that we use to conserve our natural resources. Number 3 is substitution. And in substitution, it's exactly as it sounds. You're substitute one resource for another because it's better for the environment. Because better for environment. Okay, so for example, canvas shopping bags. Hopefully by now most of you use canvas bags when you go grocery shopping and not plastic bags. That is a substitution. You're substituting a better choice for the environment. Plastic's not good for the environment. Canvas you can reuse a lot of times. Changing out your appliances to energy efficient or going with water efficient shower heads and faucets and toilets. Going with an electric car or putting solar panels on your roof. These are all substitutions, using one resource over another because it's better for the environment. And then the last tool for conservation is maximization. And this one's kind of similar to substitution, but it is slightly different in that in this you're trying to get the maximum use of a resource. Of course, the ultimate example of this is to recycle. Okay, how many times can we use the aluminum in that soda can over and over and over? So recycling is a good option, and excuse me, a good example. Also, other things, maximization. If you shop at thrift stores, instead of buying a new pair of jeans, maybe you can find a nice pair at the thrift store and you're not having to use all those resources. So it's maximizing the use of those jeans. They might not have been usable for one person, but maybe another. Buying secondhand cars and furniture. Cars, furniture. These are all maximization. They're basically all examples of recycling, but in a slightly different way. So those are the 4 tools or strategies. So again, you need to know those 3 S's and the 4 conservation strategies. So here's the conclusion. Basically, finding ways to live sustainably on Earth requires a really good ethical grounding and also good understanding of science, the natural, and the social systems that all come into play. And environmental science helps us look at these problems, pick apart these problems, hopefully find solutions, and understand where the issues come from. And a big issue is just initially identifying a problem. And the final thing there, solving environmental problems can move us toward health, longevity, peace, and hopefully prosperity. All right, that concludes understanding our environment. I hope these video lectures will prove helpful to you guys.